Really great to see everyone on the call. I'm Tony Meehan. I'm one of the founding members of the detects.sh community, former VP of engineering at Elastic and Ingame. And I'm really excited today. I have the pleasure of introducing Tudor Golubenco. Tudor is the CTO at Xata.io, one of the only serverless data platforms for Postgres. Previously, before Xata, Tudor was a tech lead and principal software engineer at Elastic, where actually he and I got a chance to work together for several years. Actually, I joke, but like my entire career has been spent trying to chase Tudor to get more opportunities like this. So like this is actually why we're here today, is so that I could just have an opportunity to hang out with him for another hour like we did for so many years. So before Elastic, he was also a co-founder and CTO of Packetbeat, one of like the early open source application performance monitoring solutions, which is really cool. Did some stints at some voice over IP companies as well. Tudor, you're a brilliant and thoughtful engineer. I'm honored to call you a friend. I'm so excited to talk with you today, and thank you for joining us.
Thank you. Thank you for having me. And for people that don't know Tony or haven't worked with Tony before, he's one of these rare people that he's not only super knowledgeable, but also makes you energized every time you speak with him. So I'm looking forward to the chat today.
Thanks, Tudor. Coffee helps for sure. Okay, so I've known you for a while, but part of today I was kind of eager to maybe learn a little bit more about just your journey into computer science and building software specifically. So I'm actually kind of curious, do you have any kind of early memories of maybe your first time experiencing with programming, or how did you get interested in building software?
Yeah, sure. That takes me back. I think I have to thank mostly my parents for my beginnings in computers and programming and such. Just to set the context, this was the early 90s. I was living in Romania. Romania just went out of communism, so let's just say we were quite behind when it came to technologies and such. So basically, no one had like personal computers yet, right? There were like a few that existed in maybe like research centers and so on, but not normal computers. But my father, he was an electronist, and he just loves all this tech stuff. So he managed to build like a home computer from like parts, like the motherboard and the CPU, which was a Z80, and that was like an early partially homemade computer that was running BASIC. And I was like, I don't know, maybe 10 years old or something like this. And they show me my mom as well. My mom actually did computer science in university, but then moved into more like, again, like machine control and this kind of stuff, because the computers were not yet a thing back then, at least not in Romania so much. But she knew a little bit of programming, so she showed me BASIC and like how you can write circle and the position on the screen and the radius, and you get a circle on the screen. And for me, that like I was mind blown. Like it's like, oh wow, like this thing can do what you want. So yeah, and then yeah, I play with this basic computer, but didn't really know how to program. And back then there were also like these magazines that you could buy, and they had games in the form of basic code printed on 2 pages. So what you could do is copy all that code, and then you had the game in memory, and you could play until the next time you restarted the computer. There was no way to save it. It's like so I was typing for 1.5 hours, being super careful not to miss any because I didn't understand anything. And also the games were pretty difficult to understand because it's only like with go-tos and so on. So I was just copying it like I saw it. And then miraculously, sometimes it worked, and I had it on for the day. So that was, and then little by little got to my own games, and really knew kind of from early age that I wanted to be a programmer. I guess I was lucky like that.
That's amazing. I imagine you got a very early taste of bugs and trying to chase them and figure out why is this not working, which is probably the one of the best ways to learn. That's
Right.
amazing. I wish I had a very similar experience. I think it was like an Apple IIe at school. So that sounds way more interesting. Reading and copying games from magazines. That's pretty intense. That's awesome.
Yeah.
Um, well, you've been doing software development for a long time. I'm kind of curious, just kind of thinking back upon all of your experiences, what in your mind makes a good software engineer? What are some of the qualities, not just from a skill set, but maybe just from a how you think, sort of personality qualities, maybe the sort of the
Mm.
non-technical things. I'm curious, just in your mind, what makes a good software engineer?
Mm. Yeah, so I don't have a very precise answer to that question because I have learned that software engineers can be super valuable in different ways. Some are super deep thinkers and can think of a difficult low level type of problem and are happiest with that. Others are a lot more product focused, like can put themselves easier in the place of users and customers, and they are super valuable. Others are creative, design oriented. They build super beautiful UIs and so on, and they are also super valuable. So it's like I don't know if it's anything in particular. I guess in all these cases, what matters is having and spending enough time doing and getting really good at your skills, and using your advantages. Um, yeah, I don't know.
Yeah, I agree. I think from my perspective, the things that tend to stick out, whether you are a designer working in the front end, back end, low level, like embedded systems, you often see kind of similar qualities across those different domains, like curiosity and
Hmm.
maybe like some kind of hard-headed tenacity to not give up whenever something's
Yeah,
not
yeah,
working. Like those two tend to stick out whenever I
right.
work with people, is
Yeah.
no matter if it's JavaScript or assembly,
Yeah,
those two
yeah.
tend
Not
to,
giving up. I
yeah,
think that's
yeah,
like whatever you do, just stick with it kind of,
yeah,
and you'll figure it out in the end. Yeah, yeah.
exactly.
Like with those basic programs, right? It
Yep, yep,
it took a long time and it was error prone, but in a weird way, maybe that helped me in
yeah,
training, kind of like guitar training or something like this. Um, yeah, and like this never goes away. It's like today I was writing earlier some code, uh, and I had to interrupt myself because my Docker machine was out of this space, so I had to reboot that. It turns out my whole computer is out of this space. I have to troubleshoot that, figure it out, and so on, reboot. So in the end, it's like uh, a few hours of my day kind of went on this sidetrack, and I think that happens often. It's like this example with the computer is stupid, but you do this whenever you learn a new framework, a new library. It takes a while to get good at it, so just stick to it.
yeah, yeah. I love figuring out why something is broken. The only downside is that it often consumes way too much time. Like,
Yeah.
and sort of it goes by quickly when you enjoy it, but
Hmm.
it's hours of time just trying to figure it out.
Yeah.
Okay, so I saw you talk about this not too long ago, which I actually did not know that this is the 50th year of SQL. It's celebrating its 50th year
Yeah.
maybe a couple of weeks ago. And maybe with that as sort of a backdrop, I'm curious to learn a little bit more about Zeta IO. Maybe why
Hmm.
focus on Postgres? What is serverless databases? Would love to hear a little bit more about Zeta.
Sure. Yeah, so we are Xata. At Xata, we're building what we call a Postgres platform. That means that you get a Postgres service, a serverless one. We can talk a little bit more about in which way it's serverless, but you get a few things on top as well. And then on the things on top, we focus on things that are common pain points that that companies hit when using Postgres. One is replication in general. At the moment, we do replication to Elasticsearch. So if you are using Postgres and also Elasticsearch for search or aggregations and so on the Xata platform, that's kind of happening all the time. So you don't have to do anything about it. Then we have support for file attachments, which makes it easy to work with files stored in S3, but they act as a column in your database, so that we make that part simple. And then we have other improvements around schema changes. This is a common pain point as well among our like our users and customers. They like if you ask what's difficult with Postgres, it's quite often schema changes, one of them, and a few other things. But these are the kind of like the main points. Because you mentioned SQL and it being 50 years old, we actually didn't start like that. We were initially like we built it from the start on top of Postgres, but we were not exposing the Postgres wire protocol and therefore SQL. We are having our own API, like REST-like API to work with your data, and we have our own TypeScript client and Python client, which are really appreciated because they make it easy to get started, and it's all from one vendor. So you know, like if you use our SDK, you know for sure that that's going to work and you're not going to have problems. But the issue is people there's maybe a couple of issues. One is that people want a lot of long tail functionality that it's hard to put everything in an API, and it already exists in SQL and in Postgres. You know, like random stuff like I don't know, sorting by multiple columns or things like this, just to give you an example. And we could add those one by one in our API, but that will take a long time. And if you ask people, okay, tell me what functionality you need, and we're going to add it, they will say, well, I don't know yet what I'm going to need. So I actually need everything from SQL in order to trust you to put my database on your platform, right? So that's why we said, okay, I think we do need to support SQL, at least SQL over HTTP. And the other part of the story, and another reason, is that people have their own tools and over the last 40 years, you know, like Postgres, it's also like 40 years old or something like this. There have been a lot of tools built for SQL databases and for Postgres. And people have their own favorite ORMs, they have their own favorite data exploration tools, BI tools, and so on. And they want those to keep working, right? So then we did a little bit of a pivot, if you want, and we made it in such a way that we're offering the Postgres, so it's in a way like a Postgres service, while still keeping all the things that our customers really liked about Xata, which includes the SDK, the automatic replication to search, the schema changes, improvements, the migration workflows, all this kind of stuff. They were good things, but people also wanted direct access to Postgres. So yeah, that's kind of the story. We're basically more or less just finished to do this. It's currently still in beta. We're hoping to, like, the Postgres access to the data platform is still in beta. We're hoping to have it out of beta relatively soon. Yeah. So yeah, I'm excited about all of that.
That's awesome. You actually mentioned something that I'm kind of curious to learn a little bit more about, and maybe it's worth talking about it in the context of this project, this tool, open source tool you just started working on
Mhm.
as a company a couple of months ago, PG role. So
Mhm.
you mentioned something about schema migrations and some of the challenges people face there. I'm kind of curious, maybe could you talk a little bit more about that problem,
Mhm.
how it causes issues for developers and sort of your approach to helping that go easier? And it sounds like with this open source tool, whether or not you're using Xata, you can do something today with that PG role to help you with this problem. So I'm kind of curious to
Yeah.
learn more.
Right, and that's also part of our strategy. We want to open source more of our work because when we started, it was all kind of monolithic into the Zeta service. But we want to, if you want, break it a little bit into pieces and then open source the projects individually so that people can they're basically open source projects with their own life cycle and so on, right? And PG role, so the problem of schema migration is quite difficult. And it's something that we have been thinking for a long time, basically for as long as the company has existed, especially in the context of providing a nice repeatable workflow. Because in Zeta, we also have this idea of branches, database branches. Um, which are pretty popular now among the like the newer database provider, like Planescale has them, Neon has them, we have them, and then I think there are others that have branches as well. But the point of branches kind of is to help you in your developer workflow to make schema migrations, because just if you like in many of these platforms, you can create branches from your main branch, you can test your changes there, but then it's up to you to figure out how to get that stuff in production. And what we wanted is to have kind of the complete experience. You branch, you apply your schema changes in the branch, you test them there, like staging or something like this, and then you merge back in production. And when you merge back in production, the idea is that whatever schema changes you did in your test branch, in your preview branch, they are applied to your production database as well. But that and that sounds like relatively simple conceptually. Uh, where it gets really hard is when you have constraints in SQL, like your data has to be consistent at all times, and consistent might mean that the column, if it's marked as unique not null, then it needs to be unique not null the whole time. And also things like when you need to change the type of a column, like let's say you had something that's a string and you change your mind, you want to convert it to an int and so on. These are the type of things where you kind of need to do some sort of data backfill. And those are difficult, and there's like many cases, and people have all sorts of workarounds to apply them. Like GitLab, for example, has this huge handbook on how to perform safe schema migrations. And it's a pretty long one, and it goes through all the cases. Like you want to rename a column, how do you do that? You do it in a few steps. You add the name, you backfill the data into the new name, you remove the old one. This needs to be in sync with the application. So in the end, you need to do multiple PRs to do such a simple operation like renaming a column. And then adding a column that's a not null, that's also difficult because the database needs a value for all of them, right? Not null with a default value, it's easy. Not null without a default value, that's difficult. So there are all these type of cases. So we thought, well, if we really want to solve this problem, ideally we would want that the process is always the same, and ideally it would be that you merge the database branch and then you merge the application code. But what that means is that the database has to be has to be able to serve both the old version of the schema and the new version of the schema, depending on the application version that it is. And if you can do that, then the whole thing becomes pretty simple, and you don't have these 5 steps to rename a column, and you don't have to figure out how to backfill data and so on. It's all done by this database, by the database system. And that's what pgrole does. And it uses, in order to do that, it uses Postgres views. So it's the physical the physical table is the same, but what it does, it creates a view with the old schema and the view with the new schema. And let's say you want to change the type of a column. The way to do is that it adds a new column, but that's hidden in the old schema. It converts the code, like it does the backfill, and when it's ready, it publishes the new view as well. And that from then on, it's safe to upgrade your application. And even if you do something like a rolling upgrade and you still have the old version of the application and the new version of the application, they will both work. This is the guarantee that pgrole has. So yeah, we think that's a really good overall approach for schema changes, and it's something that it's an open source project. You can use it with Postgres, any Postgres hosting service, but in the Xata platform, it comes kind of built in, so it's already there, and you can use it. Basically, all the schema changes that you are doing on the Xata platform, they actually go through pgrole behind the scenes.
Yeah.
So yeah, that's like a good, we think a really good differentiator for us.
Yeah, I mean, I was telling you before we started this call, like I was putting in some PRs on my end and doing some work, and it was almost all of it was on schema migration and Postgres. So
Yeah.
yes, it is. We all suffer from this, and I think that's really cool that you not only are you doing this for your own customers, but you've got this now open source project to help anyone out that's using Postgres, which is I think is awesome.
Yep.
Well, I'm eager to get into some topics around when software breaks, and maybe we can start just in the context of Xata and what you've built. I'm just kind of curious, as you think about your architecture and building a serverless Postgres platform, like where do things start to break at scale? What are some of the unique challenges of building software that scales, and maybe specifically in the context of Xata? What starts to break when you've got a lot of load on the system, and just how do you think about building an architecture that can kind of grow with the demand?
Mm-hmm. Yeah, so in general, in terms of growing with the scale, it's for us, it's provisioning things, right? Like when we get surprised by a load increase, then usually the solution is to increase some of the allocated resources. And I think we talked back in the day, we started by using ECS, the AWS ECS, like it's a fairly simple container service, and it has some ability to auto scale and so on, but it's simple. It's not trying to be, Kubernetes. So now we are actually migrating to Kubernetes so that we get more control into those things. So yeah, there's stuff like that going on. Then it's also pretty specific to us, but we use shared clusters on the small scale, and then you can have dedicated clusters if you want to. But on the shared clusters, we have this noisy neighbor problem, where if a user starts to really hammer the database, either with like a huge data import, or by doing very expensive queries and so on, then it can affect other customers on the same system. And we have our mechanism in place to limit those things, but sometimes they still happen, and that's something that we have to deal with. So things like rate limiting, concurrency control, these sort of things, to get control of the of the situation.
Got it. But maybe you recently had an interesting problem with feature flags in the
Mhm.
platform, and I'm wondering what can you share with us maybe about that problem? How did you first detect
Yeah.
it? Maybe we start there.
Yeah. Right. So yeah, we first detected that we cannot deploy, like our PRs didn't. I think it was not even that we couldn't deploy. Our PRs were failing tests more often than normally. So the PR were becoming red. So that's what we've noticed first, and um, and looking at, like doing the normal thing, looking at where it fails and so on, we realize, well, the tests don't even run. There's a GitHub rate, there's a GitHub rate limiting error. And we learned a bit later that GitHub has this API rate limiting on their API, and you can do 5,000 requests per hour. And initially, it was an evening a couple of weeks ago when this happened. We started to get these errors during our CI run, but we thought it's only somehow our CI. We didn't think that this could affect production in any way. So we were not too worried about it. It was getting late, so we say, okay, we'll figure it out tomorrow morning, right? And luckily, nothing happened until the next morning. But what we didn't realize is the same API key that was getting rate limited was also used in production code to pull our feature flags. So we use this Go feature flags library, and what it does, it downloads a file from GitHub or from S3, or I think it has a few options, but we had it set up from GitHub. It downloads a file with the feature flags and what they are set to, right? And we use this a lot for all sorts of things, like to roll out features little by little, to enable them only for some workspaces. We have all sorts of use cases for feature flags, so that's used quite a lot. And by the next morning, the situation has aggravated to some degree, because, as I said, there you have 5,000 calls per hour, and we are consuming them in like a couple of minutes during that, and the rest of the 58 minutes in the hour, that was completely not working, right? Luckily, the feature flags implementation was smart enough to only do it async and didn't block any work, and also didn't. So if the read of the feature flag fails, all the feature flag keep their existing value. So it was not an immediate problem. That's why we didn't notice it in production. It didn't cause any issues in production yet. But yeah, the situation was a little bit tricky, because if we would do a deploy and the download of the file would fail, then the feature flags will have their default values, which we quickly looked, and it was not good, because we were not very we are not very attentive in having the default value be the safe approach. So we would basically disable some functionality that customers required, like files, for example. Files used to be behind the feature flag, then we make the feature flag default on, or it was always on in the file, but the default in the code was still false, right? So that if it would have downloaded it would get an error at the deploy time, then you would it would be the default value, which is false, and basically would have disabled file attachments for all our users, which would have been quite bad.
Yeah.
So we had to be quite careful about getting out of that situation.
These problems, I think, are fascinating for a variety of reasons. I have seen other examples of throttling having impacts where a team was doing something in a QA environment that had some issue where it caused pods to restart in their Kubernetes cluster, and it was happening so frequently that they hit a similar API threshold limit for container downloads.
Hmm.
and it was a QA environment, and so they sort of thought, well, okay, that's a problem, but it's just QA. But production and staging were also using the same container service, and the same API throttling limit was hitting them there too. It seems like
Yeah.
a very similar cascading
Yeah.
failure that
Right. Right. Right.
that they're always interesting to me. I think another thing that's interesting to me is that you could have a ton of metrics and traces and dashboards, but this is still kind of a hidden problem. I'm
Yeah.
wondering if you could
Yeah.
maybe talk a little bit more about that. You know, how in this problem did this sort of feel like a little bit of a hidden issue that was sort of, even if you had all of these observability and metrics, it was still sort of underneath all of that.
Right. Yeah. There was like definitely business metrics were not affected, which is what we tend to page on. Um, but there was nothing in our alerting system or anything to notify us of this particular one. We could have, like in retrospect, we could have monitored errors on downloading the feature flags file, but we didn't do that. We didn't have an alert on it or anything like this. So we didn't know. We realized it can affect production just by figuring out what the API key is. Why are there so many requests done by that API key? And then we realize, oh wait, the production is actually using that API key. That's not good.
Yeah.
that's
It's
that's not.
funny that you could spend so much time getting all of this data in a dashboard and think, okay, good, we finally have visibility into what's happening. But like your journey is just beginning now. You have to know, okay, well, what are the problems that I need to be looking for, and how do I detect
Mhm.
them? Like in a way
Yeah.
that, like it seems like in this problem, I'm actually kind of curious about this. Like who looked at the error and sort of went from that's interesting to like, oh wait, we should probably look into that some more, because it's almost
Mhm.
a little bit element of luck, but probably a ton of
Yeah.
skill and
Yeah.
experience too.
Intuition to some degree. Yes.
Yeah, yeah.
Yeah.
I mean, and that's the thing that's always scary about most problems that I've seen too, is that there's almost always some person that's got a lot of experience that looked, said that's weird, and they just kept going to
Yeah.
ask questions, and finally, oh wait a minute, this is a problem. So I'm just kind
Right.
of curious,
Right.
what's that story here?
Yeah, in this particular case, we had to look into it because our PRs were failing CI, so developers couldn't work. So it was a developer that was trying to get his work done, as I said at the end of the day, and he couldn't get like the PR to turn green. So he looked into that. But yeah, as I said, we initially concluded it's probably not affecting anything else, but so we left it for the next day, and the next day we continue to troubleshoot where it is and so on. But yeah, this was failing us a little bit on the mental model that we had. It's like you're always building like a mental model of how your platform works, right? And that's where that intuition maybe comes a little bit. And in my mental model, a CI failure, like test failure in a PR, should not never affect production. It was our mistake that we use the same API key, and that's where it, that's where it broke. Um, but yeah, it's like, and that's kind of why it was surprising in a way. And I thought the incident is interesting because it broke out of the mental model. And then it's like this mental model, I had it pretty good in my mind for like the first 2 years of the company. But as you add more people, you add more code, you change things, new systems, it's hard to keep it accurate. It's also at some point it's simply too large to have it in a single person mind. We're not there yet. Like I think our stuff it's still relatively simple, but yeah, I'm sure Netflix or Google, they would have this problem, right? But in our case, you could still do it. You could still like understand how it works, but there will always be like small things that take you by surprise, like it was in this case.
Yeah, it does seem not just maybe in the example of Zeta, as you grow your product, does the complexity increase and it's harder to keep the model in your head.
Mm-hmm.
But just
Mm-hmm.
also generally speaking, over the last 20 years with more frameworks and abstractions, it's
Yeah,
often harder to understand a little bit of the what's actually happening underneath the hood,
yeah,
so that when things do
yeah,
break, it does
right.
sometimes seem a little bit more opaque.
Yeah, yeah, absolutely. Like, I mean, because we're doing this transition to Kubernetes, and I mean, there are like a lot of code written by someone else, and that, you're trying to form a mental model about it, but you're going to simplify it a little bit in your mind, right? So you're not going to have the exact view. So that makes troubleshooting a little more difficult, and I guess,
Yeah,
you're learning through experience.
exactly. And I maybe to that point, I mean, it does seem like, I mean, having worked with software for a little while, it's inevitably going to fail. Often in interesting and unexpected ways, a lot like what we've just been talking
Mhm.
about. And it does usually take someone with a certain skill set or experience or intuition to kind of, again, maybe have that curiosity and that tenacity to really pull the thread a little bit to figure out what's actually happening. And I'm curious, just from maybe your experience, what makes a good troubleshooter?
Mhm.
What is it about that skill set that you need to bring to problems like this?
Mhm. Yeah, so the way I always think about it is to kind of split the problem, do a little bit like a binary search. Like if you imagine a pipeline, if it's a pipeline, it's usually actually easy to do this. That you would kind of look into the middle of it. Okay, this still makes sense. Then you look into the first half, in the second half. If that result in the half doesn't make sense, you look into the first half, and so on. Like you're looking at intermediary results to see if it still works, kind of. And if it's a pipeline, that's pretty easy to visualize. But this works, I think, in any type of system. It's like um, you start from, okay, functionality X doesn't work, but and then you say, okay, let's see, is it a backend issue or a front end issue, right? And you're looking at the request created by the browser to see if those are created at all, if they look correct, and so on. If they get an error, what error it is. If it's 500, okay, then it's definitely a backend issue. It's like, I think this is uh, this is how it usually goes,
Mhm.
right? You try to split the problem. You identify as precisely as possible the component that's causing the issue, and then you take that one and you troubleshoot it.
Yep,
Right.
yep. I mean, it's exactly how I think about it too. It's often, when there's some problem, I think of like the first 30 minutes of building up the context of that problem. It often entails two things. One is building a model or a map of the dependencies of, okay, what's this thing? What does it
Yeah.
do? What to talk to? What's that thing
Mhm.
talk to? And sort of building up this almost like a graph in your head. And
Yeah.
then on top of that graph, you're going through all of these different data sources in different places and
Mhm.
finding kind of
Does it match
breadcrumbs and
or not?
evidence and building a
Mhm.
timeline
Yeah.
through all of those physical assets or things. And then either coming up with a hypothesis that's ruled out by the data and evidence or supports it. And then
Yeah.
just reiterating that process over and
Yeah.
over and over again. It's like a eureka moment. Like, oh, that's awesome. And by
Yeah.
the way, that's like the most exciting thing for me is that moment of,
Yeah.
I
Yeah,
think
I
this is
love it
it. I
as
think
well.
there it
Yeah.
is. I'm sure you
Yeah.
had that
Yeah,
with
yeah,
the
I love it.
conversation
I
too.
I like, yeah, I kind of like this like troubleshooting, and especially in cases of incidents with adrenaline and so on. Actually, I actually like that.
Yeah,
Of
yeah.
course,
It's
we're trying to avoid it as
yeah.
engineers, having to do that. And now
I
that I'm growing older, I hate it when it's during the night.
Yeah, yeah. Lyndon and I were talking about this once where I'm the same way. I love those situations. I just think that it's very rewarding to get to the sort of bottom of something. It's basically like a detective story almost.
Yeah,
But
yeah,
from
like a
Lyndon's
murder scene.
perspective, as a product manager with customers that are really struggling with this, it's not fun at all, and it really isn't for customers. So it's a two-edged, double-edged sword, I guess.
Definitely, definitely. Yeah,
Yeah,
yeah. And we're like, we're putting a lot of effort in making this not happen, right?
yeah, yeah.
But the raw feeling of solving it when it happens, because you are under time pressure and you have to think fast, and gather all this information as soon as possible, that's actually a nice nice
Yeah.
feeling.
Yeah, and I think a thing that I'm super passionate about is just trying to think of ways in which that cycle to get to the eureka moment can be faster. Because I've had experiences where I've, probably spent 3 days looking into something, and then, day 4 in the morning, I'm just looking at GitHub issues. I'm like, oh no. It's a thing that people have been struggling with for a long time. You see all of these like Me Too comments on the GitHub issue, like this is also happening to me. And it's just this like daunting feeling, going back to the just growing complexity of software. It's this overwhelming feeling of how the heck am I going to keep up? But it's still fun. For the people in the call, we'll have time for questions at the end. So start thinking about them now. Definitely put them in chat. We'll go for a couple more minutes here, but would love to open it up to the room for any questions from the group. So maybe Tudor, one or two last questions for you. I was reading one of Zeta's recent blog posts. Actually, I think you wrote around Postgres extension you're working on in Zig, and
Mhm.
actually, I think kind of like buried deep at the very end of the post, you teased that Zeta maybe is working on a distributed Postgres. And so I'm
Maybe.
kind of curious, what can you share about that? If anything, and what can you say about your approach to it? And maybe we start with why is a distributed Postgres useful in the first place?
Yeah, totally. So, first of all, it's again, speaking with like our users and customers and prospective customers, and even other companies. Uh, there's the issue is there's not that many reasons for which a company would consider changing their core database, because it's just such a difficult migration always, so they would have to be really unhappy with their current provider, or maybe get some, like if it's a 10x cost difference or something like this, maybe they would embark in that. Um, but otherwise, there are not a lot of reasons for which people would actually switch databases. But one that actually causes people to switch is scale issues, like performance at scale, or just limitation at the of the technology when it comes to scale. And Postgres is, for the most part, still kind of like a single writer type of system. Um, you can have read replicas for, especially if you don't need your reads to be consistent, you can have that, sure. But still, all the writes and all the reads that you need to be strongly consistent, they need to go through the same single instance, right? And you can have fallback, so it's not so much a problem of single point of failure, but it's a problem of scale. And in RDS, you can get now huge huge servers in terms of RAM and number of CPUs and so on. But that's pretty expensive. That's one thing. And the other thing is that's still limited. And another issue is that it also means if you have really a single database that needs to be in a single geographical location. So then if your customers are split over the whole world, people in Australia are getting usually pretty bad experience accessing websites and applications that only have US East 1 presence, like all the data is in US East 1, which is, like the typical choice.
70% of the internet.
Yeah. You used to live in the area, so you have no idea what problem I'm talking about. Um, right. So it is and then there's when people reach this limit of a single writer or single node Postgres, then they have a couple of options. They can switch to something like CockroachDB, which offers the Postgres protocol, but it's a significantly different implementation under the hood, right? It's based on a distributed key value store. It's a complete re-implementation, which means that some functionality that you might have in Postgres, it doesn't exist in Cockroach or similar databases, right? Like a good example is maybe pgvector. It's super popular now. A very good Postgres extension for vector for similarity search and such. They don't have it in Cockroach. Maybe they have another implementation. I don't know, but not pgvector. And there's other examples like that as well. Or they can do their own sharding in the application layer, which is what, for example, Notion chose to do, what Figma chose to do, Robinhood, a couple of others, and they documented how they did their own sharding for Postgres. But that's a lot of work. And it's like I think they were saying there's like huge amount of work that went into that. So we're thinking of doing this project. We don't have even a name for it. We have kind of like a POC where we just make this simpler, like this sharding, so that you don't have to do it in the application or not completely in the application. This project will take some of the work and effort into doing that. So then people, could stick to Postgres even beyond this natural limit of a single node system. That's, at the high level.
That it sounds actually, I mean, it sounds amazing. Just not just from managing schemas is one thing. That's definitely a big challenge, but yeah, I mean, I almost every database system that I have worked on has definitely been more of the traditional Postgres, one or two servers in one region. And so to be able to pull this off for your users seems like that would be amazing. But I'm also sure it adds, thinking back to complexity, more and more layers of complexity. Maybe
Yeah.
what are some of the things, the new challenges building a distributed Postgres can introduce? Thinking of the types of failures, unexpected things that could happen. What are the things that you kind of have to worry about as you build a
Yeah.
distributed Postgres?
Yeah, it's definitely a difficult problem, because if it was any easier, it would have been done by now. And there have been attempts, so that's definitely that's not the issue. There was Postgres XL and then Citus, which actually is probably the best solution at the moment, but it's fairly hard to adopt and so on. So that's I think we can do better in some regards. And Enterprise DB has a distributed Postgres product as well, but it's not open source, so I don't know too much about it to comment and such. But it is a difficult problem, and the reason it's difficult is that one of the core technologies in Postgres that makes it so good is the planner, which takes your SQL query and figures out what's the best plan to get to that result. And but that planner only assumes local access, right? And if you're introducing latency, then the cost optimization function it's going to be different. So that will, in order to do that correctly, you need to hook into and modify the behavior of the planner, give it more information, and so on. You would also need to figure out how to, like, imagine you do like a select sum of a column or something like this. That sum implementation is relatively easy to distribute it among shards, but you have to do that for all functions, right? Like sum and count and so on. They are pretty easy, but others are going to be more complex and so on. So you have to do each and every one of those. And then finally, and maybe even the most challenging, is when you do distributed transactions. So when you do transactions in Postgres, you get these guarantees, right? Like they're ACID transactions, and ideally you would keep those. And there are ways to do distributed transactions, of course, but with the added latency, the performance is suffering a lot, right? And there's no real way to avoid that performance impact because it's just a flight of speed limitation. So that's not, it's just going to be a lot slower than local transactions, right? So our thinking in that space is that we will have distributed transactions for when you need them, but the best thing is to not need distributed transactions, basically. So we're going to put effort in collocating the data correctly, so that data that's related ends up in a single node, so that when you need to work with it, it's basically already on a single node, so you can do a normal Postgres transaction. You don't have to do like the distributed one, which will have the performance penalty. So this is, like one of our ideas that um, we can invest or figure out how to smartly put the data so that it's correctly collocated. And in some situation that can be, like easier, in some situation is harder. But yeah, let's see
Yeah.
how far we can get with it.
It sounds like you have your hands full, but that would be amazing to pull that off. That's really cool.
Yeah.
Maybe it looks like we have a question from the group here. So I want to get to it, but I had one last one that I wanted to ask. So we have about 5 minutes left or 6 minutes left. Um, I'm just kind of curious, maybe from your perspective at Zeta or in your past career, how do you think about like your time, allocating your time to kind of proactively looking for problems,
Mhm.
or just waiting for them to come to you? Because again, you're often
Yeah.
balancing your time building features, but also you want to make sure that there aren't any problems that are being experienced by users. So I'm
Yeah.
curious, maybe how do you think about that balance of your time, and maybe over time as you build products, like where does it tend to shift? And so just would love to hear
Mhm.
you kind of talk a little bit about that.
Yeah, I'm not sure I'm doing a particularly good job on that. I don't know if I'm the person to give advice on this. Um, but yeah, as a company, we're looking at what we can do in the next 3 to 4 months. We split kind of our work we do our launches in what we call launch weeks, which means that every day of the week we announce something new, which we found that from a like marketing point of view that works pretty good, because you create this momentum all in one week, but not all in one day, which then the features compete with each other. So that's not ideal. So we do launch weeks, a feature each week, and so on. So now we're using that kind of external, like marketing thing to plan. So basically, right now we're looking for the next launch week, and we're saying, okay, what would we like to have by then? What do we think would help our customers? What do we think will make us stand out, and so on? And then we're prioritizing those things. We do, yeah. It's probably my fault. We do tend to do quite a lot of things, probably too much. So we might have to like reduce our work and focus on like fewer things. Uh,
I mean, what's fascinating to me about hearing you say that is I've had an opportunity to talk to many different, engineers, CTOs, and you definitely get this similar response of, well, it just on our end, we're unlike other people. We can't keep up. We just have to do features. We're not able to go and just spend time looking for problems. We have to wait for a customer to tell us. I mean, it makes sense. Everyone's like this because we've got to deliver value to our customers, and it's hard to allocate time because we've already talked about it. It's a ton of manual work to figure out why something is broken.
mhm.
So I guess maybe that's all that is to say. The grass is not greener on the other side, Tudor. We're all suffering. It's
Oh, I
all a
know, I know.
problem.
Yeah. It's like every time you see like a company from the outside, you think, oh man, they are doing great. They have all this stuff, and then you're speaking with someone in the inside, and then they're like, oh, it's such a mess. It's like
Yep.
impossible. I cannot
Yep.
keep up. There's so many problems, and so
Yep.
it's always like that. Yeah.
Yep.
So it's like it's
A question from the group here: with your current products, Tudor, How often are you shipping to production? And maybe what are some of the roadblocks that you think of that prevent you from moving even faster?
So on that side, I think we're doing pretty good. So we're shipping to production every day. Our PRs, when they are merged, they get automatically to staging, and then they need an approval in GitHub. And if they get that approval, they are shipped to production immediately. So that the feedback is, and we use these feature flags that we were discussing earlier. We use these feature flags to sometimes hide features from customers because maybe they're not completely ready, or because we want to test them first ourselves, you know. But we are shipping basically every day. We discussed should you ship on to production on Friday, yes or no? It was quite a debate maybe a year or two ago. We have decided to go with a compromise. So we don't ship on Friday after 2 p.m.
That's amazing. Well, Tudor, I think that is all the time that we have. Look, if I could find excuses to hang out with you for an hour a week again, like in the old days, I would. But unfortunately, we cannot. But I want to just say thank you so much on behalf of detect.sh and the community. This was an amazing conversation. Really appreciate your time, and thank you for joining us. And for the rest of the group on the call too, thank you for joining us. Definitely give maybe in the chat some rounds of applause for Tudor. But Tudor, thank you for your time, and thank you for joining us.
Thank you so much for having me, and really enjoyed the conversation.
It was great.